Hello, Sodor fans. So my name's Sam. I'm lead for electronics on Sodor's Railways, mainly because of passion and I'm used to this at scenery as I've mentioned before. Um, Due to COVID, at the moment we've got a lot of the work going on in our own homes as opposed to us all being together. So I am hooked up in my spare room at the moment. Today we're going to go through the start of how Sodor's electronics work and the proprietary decoders that we use. I will apologise in advance. I did have a bit of dental treatment this morning, so I may be speaking a bit funny. Switch the camera over. So this is one of our boards at the moment. As you can see through storage and my manhandling, some of the fencing has broke off. But what we aim to do is make everything that is fragile like that removable anyway. So Rich will be reviewing that in the coming future. So this board here is what links the main layout to the turntable layout. Main layout coming across these boards here, and then turntable going off to here. Here we have where the coal hopper will be going, and that's under development still. A lot of teething issues with that. So today we're going to go through basic use of feedback modules, including buttons, how that's shown on iTrain. This is just here on the screen, and we'll go on from that in future episodes. So a mouse on there just was got plugged into main computer here. In short, we've got a push button here, which is what our visitors use to turn and operate the turntable. So if we press that, you'll see the button flash up there. Now, and you'll also see the turntable move in just a moment as well. So that indicates straight away that a button has been pressed. That's via DCC ExpressNet, and that gets registered with our command unit, which we discussed in a previous episode. So we press it again, the turntable will start to move in a moment, and notice that a circle appears, and correspondingly the turntable moves around. This is set for a full 360-degree cycle, just to amuse children. Obviously, when in use, it can be configured to go into any of the separate sidings. At a later time, we'll go through turntable movement and how that's built in and configured. Hole here, which is for one of the infrared sensors to come up. Basically, one of the trains would shunt backwards here. Once we hit the infrared sensor, it would stop. So our train would recognise that. And then a couple of holes here for some of the DC plug-in lights that we have, and we remove after every use, so damage to those. Point here, you notice there's a rod here. We use piano wire for that. That's hooked up to a servo underneath, which we will show in a moment. Train detection. One of the big aims of Sodor is to make it as autonomous as possible. That's so that the operators that we have are able to interact with the visitors and really engage them, which is what we want in order to do, engage adults and children alike. How it works. So we've got three tracks here, and then the two interlinking here. So if I put my hand onto there, we'll just move up to our train for a second. So I've taken my hand off, I put my hand on, it picks up suddenly that there's current being drawn in this section of track. And likewise, we can do that here and then here as well. So at all points of a train, something that conducts electricity, i.e. a loco, goes onto any part of the track in Sodor, iTrains knows where it is. If it's routing, which is represented by this yellow and red bit here, it shows where it's wanting to go. So for example, it recognises Percy is in here and wanted to come out here, hence it locks points in use. Okay, similar to a real railway. So the underside of the board, we've got a couple of things going on. So we've got the push button at the top here, which is what we discussed. A couple of wires going there. You've got your 5 volts to cover the colour and power it on, and then you've got your feeds that then go into our feedback module just there. You've got infrared sensors just here, which we'll cover in a later episode, and then also the main connecting block for the layout. ExpressNet is fed differently, so you've got this Ethernet cable here that goes back to our control box as well. I'm a fan of these pushable and very easy to use terminal blocks. Cheap from the likes of AliExpress, 100 for £2 or so. They just make chop and changing and testing a lot easier and far more convenient, as opposed to struggle with screwdriver, especially when you're underneath the layout. You then got another couple set of wires coming from here, again going into our feedback sensor just there. This is for a little button just croop around the side of the 3D printer here. A little button here, that is what covers our coal hopper when it's in use. So, where do we begin? Servo. This covers the point, and we'll show that in operation in a moment, where it sways to and from. And then also coming back to the removable DC plugs, some custom 3D printing housing here. So this covers the female socket that's in there, and then also the male socket comes on the inside and lodges into place. So well spaced and obviously protected at all counts as well. So the servo. I am a big fan of servos. I initially came across them on a small layout that I started to develop when I came back into railways, since being a kid, and the thing that drew me to them was cost predominantly. I like building on a budget and seeing what we can achieve for a low budget. And then later discovered that actually they're far more configurable than your typical solenoids, and therefore greater use. So with iTrain, for those that haven't used it, quite simply clicking on a turnout here, for example, will change the direction of the turnout and move the corresponding servo that's assigned to that. So as I press it, see that the servo then moves, and that changes the point blade correspondingly to and from. Very, very easy to use. You can get a pack of 10 servos for £10 thereabouts, again from AliExpress or eBay. So again, very cost effective compared to solenoids. So we have the IR sensor just here. Now this one is currently stowed away until the coal hopper is ready. As mentioned, the plan is that a train goes over an IR sensor we've got a mounting for, sends a signal back to iTrain, and correspondingly stops the train straight away. Now you can see that there's quite a few wires there. Essentially got 4 per IR sensor. The power, which is 12 volts to the board itself, and then you've got the 3 wires on the bottom right just here that is sent back to our feedback sensor, and then correspondingly back to our control box. In short, we hover over an IR sensor, for example, there, and it checks that its light is being reflected back into it. At the moment they're set for a fairly short distance, however can be extended to about 10 centimeters if need be. The advantage of using these is that they can be used in any circumstance. They can be used in tunnels, pitch black, or in daylight without any effect. The small hiccup that we had was Richard and his big hands sometimes whilst moving locos went over an infrared sensor, which then makes iTrain think that there's a loco there unexpectedly. iTrain is fail-safe will then stop all movements just in case we've got runaway trains, and it's not able to manage that. That's it for this week. A very short demo of one of our smaller boards and what's capable via some DCC work and some research. We continue to research and see if we can develop things differently, more cost effectively, but also whilst making us keep interest in what we do. Next week I will focus on some further work, mainly track detection and how that interfaces with iTrain and routing. If you have any suggestions, any content that you want to see, any feedback, anything like that, then just give us a comment and get in touch. Speak soon.